In this video, we're going to talk about complex numbers. They often pop up in mathematics, usually when the result of an operation involves the square root of -1. Now let's start by adding this identity just for visual symmetry. And let's add this relationship, which is going to be true regardless of what we choose to be imaginary, right? Now let's do this and this. This identity can be written like this, as long as these simple rules apply. And yet again, it would be true regardless of what we choose to be imaginary. Now let's associate these shapes to these quantities just to write this in a more visual way. Let's forget for a moment the size of these elements, and let's focus on their signs so these combinations also work. And yet again, it would be true regardless of what we choose to be imaginary. Do you know what else reflects this opposite signish behavior? Now let's do this and this. Looks familiar? This choice doesn't really matter, as long as these quantities are mutually orthogonal in the complex sense. This is Newton's law of universal gravitation. And this is Coulomb's inverse square law for electricity. Let's rearrange these terms and multiply everything by 1. This is kilograms, and this is kilograms too. Now let's make the seemingly natural yet completely arbitrary decision to write this as the real part of this equation when complex variables are allowed. Here we can say that the notation using complex variables makes things much simpler and elegant. It happens not only for these equations, but also for these ones too. This notation inevitably makes you wonder about this. Describing energy in this way puts gravity and electricity under the same context, which looks nice to the eye, but remember, this notation was an arbitrary choice. I really hope you enjoyed it. Thanks for watching, see you next time.